So ladies and gentlemen, may I say a few words about our MC today. Jem has more than 15 years of professional experience gained from local and international infrastructure projects for roads and highways, site utilities design, and site development works for residential, institutional, and recreational parks. Among others, she provides leadership and direction for different project implementations. She worked closely with various multidisciplinary teams to deliver projects from inception to completion. As a GHD market leader from transportation in the Philippines, Jem fosters strong client relationship. She drives growth and develops strategic partnership while ensuring customer satisfaction. A passionate sustainability advocate, she integrates sustainability principles into every project. She stays updated on industry trends, market dynamics, and client needs. So ladies and gentlemen, please welcome our MC, Engineer Jemmalene D. Rubiano.
Okay, good morning everyone. So I'm Rubiano and I will be the MC for today. So before I proceed with our first speaker, I wish to highlight the following. PICC will be issuing certificate of attendance to all attendees. You can request a copy from our PICC admin or you can send a request to info@picc.com.ph. Also, we will hold the question and answer after all the speakers have made their presentations. Okay, let's start. Our first speaker for today is Engineer Alrey Alvarez, a distinguished civil engineer with over 37 years of experience in construction industry. As the key account manager of Pebsteel Philippines, he has led his team to develop a strong customer-centric approach and advanced sales technique, resulting in consistent growth in key accounts. His contributions to the growth of the pre-engineering sector has been transformative, positioning him as a leader in the steel industry. Engineer Alvarez is a top graduate of Yale University and a former Philippine country manager of international construction firms in the Middle East and Vietnam. He also served as the vice chairman of the technical committee of Yate Alumni Group. Beyond his professional life, he is a pastor, a loving husband, and a proud father of 2 accomplished daughters. We are privileged to have him share his insight on the future of infrastructure today. So, ladies and gentlemen, without further ado, let's invite Engineer Alrey C. Alvarez for the steel industry, a backbone of the Philippine infrastructure.
Good morning, everyone. Yeah, it's a great honor to be in front of you, great people. No? The only constant are changes. In Tagalog, ang hindi nagbabago ay ang patuloy na pagbabago. Right? In the Philippines, infrastructure and construction industry, lots of changes are happening. And today, we will take this opportunity to introduce to all of you the biggest changes in the steel industry, the pre-engineered building system. Those are our founders, Sami Kautelli and Adib Kautelli. They are brothers. Initial investment of 15 million started in 1994 with strategic partners, Nippon Steel and Ohaya, founded in Europe. We are now 30 years in the industry, 6,000 plus completed projects, 1,400 plus dedicated team members. That is our financial capability. 100 million plus average yearly revenue. And those our bank facilities. Those our fabrication. 7 factories. 100,000 plus metric tons. Those our sales office. About us, here in the Philippines, we started in 2009, only with 5 people. At present, we have 3 offices around the Philippines: Luzon, Visayas, and Mindanao, Manila, Cebu, and Davao. And right now, that is our organizational chart, the biggest organizational chart here in the Philippines. At present, our headcount is already 70 people and still counting on. That is our office in Cebu, Davao. Those are the things that we can do. From warehouse up to aircraft hangars, 128 meters clear span without any support. That aircraft hangars, Lufthansa. That is our done projects. RLX. Right now, that is almost 10 hectares and still counting on. Those are the completed projects. That is the aircraft hangar, shipyard. That is traveling building. It's moving. Coliseum. Everything about steel. We can do that. That's warehouse. We finished lots of projects here in the Philippines. Steel mill projects. And right now, here in the Philippines, we are starting the Steel Asia projects in Lemery, Batangas. Just try to imagine, 26 meters long with no splice, 2.5 meters deep. Now, this is the major changes. What is pre-engineered building? Ladies and gentlemen, I will give you 5 seconds to read that. Okay. No? Now, what is pre-engineered building? The major concept there is what we call customize. Meaning to say, we will deliver your steel, your structural steel at site at the exact length that you need. Meaning to say, if you want a column or rafter 18 meters, we will deliver that, but the maximum length that we can transport is 11.5 meters. So that 18 meters, we'll deliver it at 11 meters and 7 meters through splicing. Right? Now, let us go to the most deeper meaning of pre-engineered building. What is pre-engineered building? Listen very carefully. Pre-engineered building is the end result when 3 members are connected together using bolted connections and acted as one member to resist all the forces of earthquake, typhoons, and etc. Now, the question is, what are the 3 members that acted as one member? First is what we call the primary members. The mainframe column and mainframe rafter. That is one member. The second one is the secondary members. That is the purlins, girt, sagaresor, and etc. The third one is the panels and sheeting. That is the primary members. The rafter and column. That is the secondary members. The purlins and girts. Sagarestor and cable bracing. Take note, everything are connected using bolts. There is no welding at site. Those are the standard of pre-engineered building components. The standard framing. The ratio of industrial building structure in the world using PEB system, they're using 80%. Other system using only 20%. Why Pebsteel? Those are the 7 reasons why we must use Pebsteel. Take note of item number 5. That is tailor-made building using tapered sections. That is the comparison of pre-engineered versus conventional. In the design, using pre-engineered buildings, quick and efficient. Conventional building design from scratch and pure design aids. Delivery, sa conventional, in conventional, that is average 20 to 26 weeks. Pre-engineered average 6 to 8 weeks. Very fast. Foundation, conventional, heavy foundation. Pre-engineered, simple design. Easy to construct and lightweight. Erection costs, 20% more expensive. Accurate, easy, and fast. Overall prices, conventional, high price. And take note of pre-engineered building. Price per square meter as much as 30% lower than conventional steel. Project timeline in a monthly basis. In conventional method, we have preliminary plans and then there is a detailed design drawing before the cost is established. But in design and build method, preliminary plans. And then automatically, we can establish the cost. Advantage of pre-engineered building. 20% lighter than normal grade steel. Why? We are using high grade steel. Primary members grade 50. Secondary members grade 65. Normal grade, primary and secondary grade 36. This is one of the advantages of pre-engineered building. If you are going to analyze this technically, if you get the internal moment diagram, you will notice here, we have a bigger section here because this is the most stressed section of the building. That is the reason why it's tapering. And also, we can change plate thickness. In pre-engineered building system, the foundation of PEB systems are fewer and lighter due to joint connection. We are using joint connection, not moment connection. Spatial shape purlins, those are the cutting plan, no scrap. This is the example of substandard poor design. That is in Sports Center in Siargao. Pebsteel always consider the location before we design the building to avoid this scenario. How can we work together? How? First, let Pebsteel design the structure. We will do the structural designing. Second, we will offer value engineering. The third one, let us persuade our clients to use steel instead of concrete. If they are using grade 36, let us use grade 50. The final one, let us offer our clients what other competitors cannot offer. What is that offer? In Pebsteel, we are the only company that can supply the Peb hybrid. Save the Raptor weight up to 20%. And those are the benefits. That is the RLX Robinson's Logistics Incorporated. We are almost 10 hectares for the projects and still counting. It's a continuous project. We are using Peb hybrid for that project. That is in Calamba, Laguna. Another thing is our Luxin. Up to 300 kilometers per hour. Very strong. No heat expansion. 120 meters continuous length. No overlapping. We can do that. And now, for the final moment of this presentation, I would like to leave a message. Listen carefully. The species that survive are not the strongest or the most intelligent, but the one who best adapt to change. So, let us travel together in a straight line road. And remember, the shortest distance between 2 points is a straight line. The first point is your company. The second point is our company, Pebsteel Buildings Company Limited. Good morning to everyone.
Good to know that the steel industry is also evolving during our evolving. Thank you, Engineer Alvarez, for that informative presentation. So before we proceed with our keynote speech, we will be taking a break. We will be back in 30 minutes, so please have a hearty lunch. All right. Yeah, so I think we can begin. I hope you all enjoyed your lunch. Let's start our second discussion. So for the much-awaited keynote speech, it is my pleasure to introduce to you our two speakers from DIA Nippon Engineering Consultant Limited. First up, Mr. KIMURA Hideki, who will give us a brief background of the DNE. Mr. KIMURA graduated from School of Letters, Arts and Science II at Waseda University in Japan in 2013. His professional career began as a business development and marketing personnel at a civil engineering consulting firm. His international achievements spreads to the Philippines, Vietnam, Myanmar, India, Palau, Samoa, Ethiopia, Mozambique, Zambia, and Rwanda. Also, he engaged in several small and medium-sized enterprise support projects, such as the erosion control and vegetation mat for slope protection in the Philippines, like the Takino Filter Incorporated, which encourages the enterprise to expand their business outside of Japan as a JICA short-term expert. On the other hand, Engineer NISHIZONO Yuichi will talk about the mountain tunnel technology the NATM design and construction in the Laguna Lakeshore Road Network project. Engineer NISHIZONO graduated from the Department of Civil Engineering at Kyushu University, Japan in 1987. He then joined a general construction company primarily engaged in mountain tunnel construction. He also has served as a project manager for tunneling construction projects 3 times, including the 7-kilometer tubes. In 2008, he transitioned to a civil engineering consulting firm to pursue opportunities in overseas projects. His international project experience includes a pre-feasibility study of the Dalton Pass Tunnel, creating a mountain tunnel guidelines in Sri Lanka, preliminary design of road tunnels in Sumatra Island in Indonesia, and detailed design of tunnels in Kyrgyzstan. Since April 2024, he has also been involved in the preliminary design of the tunnels for the Laguna Lakeshore Road Network Project Phase 2. So, ladies and gentlemen, without further ado, a warm round of applause to our keynote speakers, Mr. KIMURA Hideki and Engineer NISHIZONO Yuichi.
Yeah, thank you very much for your kind introduction, Ms. Rubiano. Ladies and gentlemen, good afternoon, magandang hapon in Japanese, konnichiwa. How was your lunch? I'm very satisfied with this lunch. So before technical input of our engineer, NISHIZONO, I'd like to give you a brief introduction of the company, Nippon Engineering. So, yeah, actually, we are Nippon Engineering now, but there is formerly called Nippon Engineering Consultant. I give you the reason why. So, this is our company overview. Our company established in 1963, meaning we have more than 60 years track record experiences. And then our capital, 1.399 billion yen, and also net sales, 33.68 billion Japanese yen. And the number of employees, we have roughly 1,300 employees. And then 70%, roughly 70% are engineers. We have office outside of the country, Japan, Hanoi, Vietnam, Ho Chi Minh, and also here in the Philippines, Manila. As I said, our company name, formerly Nippon Engineering, but now Nippon Engineering. The reason why 2 companies emerged, get one together, 2023. Our Nippon Engineering was Japanese top leading bridge engineering company, and also Dia Consultant, our partner company, was the #1 geotechnical company. Yeah, this is the ranking in Japan, in structural engineering field. So maybe you can find our Nippon ranked 1 or 2. So that's the reason why I can say we are the Japanese leading bridge and structural engineering company. And also, Nippon Engineering is listed at the stock market in Japan. Our strengths. We are only one company, the Japanese engineering company, has aesthetic design division. So we can provide this kind of good design. That is based on the awarded project. This one, yes, as I told you, we are very good at bridge engineering, especially this kind of special bridge or long span bridge. Yeah, this one is there was existing bridge, plus bridge, and then we propose new bridge, arch type bridge beside the existing one, considering harmonization of 2 bridges for landscape. Also, sometimes we participate design competition like this. Another strength. This is a part of our geotechnical engineering team, we can provide very high spec geotechnical survey. This technology is used for the survey for nuclear power plant construction in Japan. Also, this is very unique our technology developed by us. We call it airborne electric method, AEM. So I show you some picture, video live. No? Maybe there's some technical difficulties. So anyway, later, maybe, if possible, I'd like to give you my calling card, and then if I will send this video later. Video. Yes, same one, for just in case. Yes, this one. We use helicopter and this type of missile-shaped equipment. And then from this equipment, the radio wave going down. And then also we developed the for drone type recently. So yeah, we can utilize both. And then we use this technology. The purpose is grasping the underwater condition. Yeah, something like this. And then, yes, our technology will be a replacement of boring. We can reduce the number of boring using this technology. Yeah, that's it. Okay. Yeah, this is the mechanism of this technology. Maybe if you need, I will explain you later. And then this is the how to survey using this technology. Then we can find which alignment. For this one is used for the planning of road alignment. For example, this one red color is bad, soft soil condition, and then blue one is good, hard. So in this case, maybe route B is better, selecting the hard and stable soil condition. In the Philippines, we have a lot of project history, and then we started our business project in 1979. And then also we opened our representative office in 1988. This is our part of our project. And then now we are doing some ongoing project under DPWH. Yeah, this is the official information from DPWH. Maybe you can find one of them, the double city bypass construction project, tunnel project. And then Dalton Pass East Alignment. This one also tunnel project. Then now we have also completed Laguna Lakeshore Road Network Project, phase 1. And phase 2 still ongoing, the East Alignment. And then this is Arita Road Bypass Project, connect. Yeah. And then this is Metro Manila Priority Bridge Seismic Improvement Project along ESA, Guadalupe Bridge. During this project, we developed a design standard called BSDS. This one is seismic design code, a combination of Japanese standard and ASHE. So from time to time, maybe a Filipino or international expert is not familiar with this kind of standard, but we can help if you need. So our engineer Dr. Yasuda is the one who developed this manual. Also, we completed Central Mindanao High Standard Highway project, and then second Samaniko Bridge project. This is still ongoing FS. Yeah, aside from the ongoing project, now we studied some pre-feasibility of Island Connect linkage bridge project. Then, aside from the Philippines, our business project is expressed to the all over the world. We have many projects in South Asian countries, as well as African countries. Yeah, this is Nhatan Bridge, Vietnam, a very big, huge, and a very beautiful bridge. And also Bangladesh, some bridges in Bangladesh. Yeah, thank you very much. My presentation finished. And then two of us, two Japanese, me and Mr. Takada, he's there. He's our bridge engineer. And then he's now doing a lot of projects in the Philippines. So please don't hesitate to contact us. Thank you very much. And I hope you will enjoy Mr. Nishizono's presentation. Thank you very much.
Good afternoon, everybody. I am Yuichi Nishizono. So, first of all, I would like to express my sincere gratitude for the inviting our companies and us in these these gatherings. Additionally, I would like to extend my heartfelt thanks to the administration of the office. Thank you so much. So, just so I arrived at the Philippines yesterday. So for presentation one, right? And last week I had worked in Indonesia. From back here to Japan and to the Philippines. I'm so just a little tired. Sorry, I can't strong the presentation. Sorry, please listen carefully, okay? Right? All right. And at first, so I introduced myself, graduated my university. I joined the general construction companies, primarily involved in mountain tunnel project, then 50 years ago. I transferred to civil engineering consultancy. I have since been working on overseas tunnel project. This is the project, the Philippines, 3 project, Dragon Pass, the Pre-FS, and the road project to South Asia, and and Laguna Lake Shore, the phase 2, the tunnel basic design. And next, the another countries, Indonesia, the Laos, the Kyrgyzstan, so all the overseas, development countries, the tunnel, the detailed design, the basic designs. I have many experience. So at this overview, the introduce. Today I will explain mountain tunnel, and this code is a NATM. Japanese called a NATOM. This is New Australia tunnel method, which are the relatively rare structure in the Philippines, using the Alrey as a reference. However, please note that Alrey at feasibility study stage, there is a possibility that root structure may be modified in the future. Therefore, please kindly request then you refrain from taking photo the material presented today because to the feasibility study stage. Just the information only, okay? What is mountain tunnel? There is, I think so, there maybe in Philippines, the mountain tunnel, the 1 or 2. And at first, the relatively rare structure in the Philippines using a Alrey reference. However, please note the Alrey is the sorry, just a moment. What exactly mountain tunnel to begin? We will explore this question by examining the geological characteristics of Japan and the Philippines. Understanding the design and construction of the mountain tunnel, these factors significantly influence the engineering approach and the technologies required. At first, the Japanese geological proof Japan's the total land area, this one the square kilometers, and 74% is a mountain on the hills. So then, additionally, it is situated the intersection of the plate, resulting in the presence of active violence and large fault zone. These factors indicated the Japanese geologically extremely complex. This one. And so just the Japanese geological, but however, in the European, because so the geological Western Europe, the east coast of the United States, characteristic stabilities, it is different, and geological state characters. And the Philippine geological, this is the same in Japanese geological conditions. It's a very, very complex different. This is located along the particular fires and located this different. Is many fault because same the characters. So similar with Japanese geological similars between the Philippines and Japan, the suggestion Japanese advanced tunnel engineering the technology can make a significant contribution to the development of your tunnel project. As you know, there are double bypass city, double bypass on the going and constructions. So very sort this is tunnel is primarily composed of soft rock. So the just so that it's a hard condition different. And by the way, the Japanese tunnel, how the Japanese tunnel the situation status here. And Japan is a tunnel is 1 million road tunnels existing here. And so the total distance, the 5,300 kilometers in this years, this Japanese many tunnel. I have we have a technology. I have various technologies. We have it. And as a record, the Japanese this one and the 1980 the NATM and led to the graduated increased tunnel construction. However, with the nationwide road network now largely developed and focus and shift of the new tunnel construction to the maintenance and repairs existing tunnels which has become the primary changes in the recent years. In Japan, the tunnel project is the build, no, it's a repair and also the maintenance project many. And the famous Japanese tunnel, this is your Tokyo Aqua tunnels, right? The Tokyo Bay, 25 kilometers, express crossing Tokyo Bay. This structure connects to the Chiba prefecture and in Kanagawa prefecture. This is 44 kilometers and this one is the tunnel by shield machine for this use. And this is the bridge because of the guttering. And next to the famous Japanese tunnels in Tokyo metropolitan and under the tunnels, this called is a Yamanote tunnel of the very so big long distance tunnel. Maybe in the distance length is 55.8 kilometer. This one. Because those are very this cost. I think it's a very huge cost. This one. Because this is the tunnel method is a shield machine, and this is very sort of expensive. And so next to the planning and design, then I refer to the LLRM and okay, and what is NATOM? That is outline discussion. What is NATOM? The comparison between NATOM and NTM and all the type of construction method, layout of the so the LLR phase 2 tunnel and the mountain tunnel design method and the procedure is outline this. Okay. Okay, what is NATOM? And this is a new Australia tunnel method. This is the established Mr. Lavsevich, 1964. Yes. This character is the picture. This utilize the infant holding capacity of the ground itself. This is key point to the word. Capacity of the ground itself. And next, the support pattern can be flexible. And the large tunnel mechanism can be installed. This is the new Australia tunnel method, the policy. And the NATOM and all the type the compartments, this one. The no gap between excavating surface shotcrete. Because all the type is the gap surface still support. The small this is the small rock pressures. This is large rocks and rock pressures. And it's an NTM to the this is the no seam, the ground, the surface, and the support systems. This is it not okay. And next to the as you the interesting that this the project yes I have to just brief to explain. And so the products to the phase 2 in the under feasibility studies ongoing. This is the tunnel location. This is one. There's Laguna Lake here. This is the east side. West side. Sorry, west side is the phase 1. Is already DD is down. This is the west side. This is phase 2. Maybe the feasibility study is their stage. This is the tunnel section. Tunnel section is a Hala section. This one. And the inbound tunnel, the 2.2 kilometer, outbound tunnel to almost 2 kilometers. Because this is the length is same, the double bypass tunnel same. So this is the tunnel detailed map. Length is 90. This one, because the tunnel cross section is 70 square meters. Tunnel method is a NITM. And the excavation method is a drilling blasting. And different double bypass. Double bypass is a mechanical excavation. But there's in this is the brand. This is the drilling blasting with explosive dynamite gel. This one. Okay. This is the western portal, eastern portal. This one is the conceptual the tunnel portal. This one. And so design the method to mountain tunnel. First, the application, the standard design, the application of the design based on the similar condition, application, the analyzed design. Okay, this is so the application standard design is very so easy in the Japanese style, Japanese design, the style, this application. I will explain this with the application standard design. So the forward design to the select design standard, and next to do the determine the design criteria, and is this the tunnel cross section calculation tunnel cross section. Number 4, this is the geological survey, the ground condition survey, and next to the decided location, the tunnel portal, and next to the tunnel support system. In the number 7, the design, the disaster presentation, emergency facilities, and study the auxiliaries method, and the tunnel construction method plan. This is the design role. This is the design criteria, the LLM tunnel. Different to the another structure, this one. Shoulder widest is of 0.775 because the another structure, so the many 2 meter shoulder wide is 2 meter or the 2.5 meter. And in Japan, the standard, this is the shoulder wide is 0.75. Right? And this is the almost the concrete pavement is concrete. Because it is very difficult to repair the pavement. This is the figures is this the cross section calculation. This one the clearance, vertical clearance, and the road wide is the shoulders, and the pavement, the composite pavement structures. This is so the prevention standard. Prevention standard is in tunnel the emergency facilities. How many installed? Decided to the one. And this is the cross section of the LLM and inbound tunnel, outbound tunnel. The minimum distance. The tunnel center to between 30 meters at least. It's, so no effect to the exhibition to the another tunnel. This is ground conditions. This one, and this is the 3 main factor. It is so the unique comparison strength and electric wave velocity. And the boring coral condition, RQD. These are the 3 main factors we decided to the grounded qualification B1, C1, C2. And we after decided the grounded conditions, whether suitable this is support system combination, this one, these tables. And so this is the lock bolt and steel rib and the short crutch. This is the 3 the support system materials, right? Okay. This is the short lock bolt, the steel rod, and the short crutch. And so ground condition is good. It's very slight in the support system, and the ground condition is very weak and very heavy. And the support systems. And this one, the tunnel support pattern, the C1, C2, D1. This is different. The local board, and this is the invert. This invert. Different this tunnel support. And so there, we decided to support pattern and according to the geological conditions. And this one, the rock about the loading parts. Tunnel support system, the heavy, that condition is weak to the heavy, hard, This is according to the ground condition. We decided to the tunnel support pattern. And also different. So the portal support system, this is type of deal, this we want. The for pouring, this is arranged. This one. That is the different. The portal support systems. And tonal location is so very designed the factors, important factors. It is best and tonal portal. This one is to the contrast to the angle. This one it's very the good portal locations. And next to the construction method. So, but this is next to the. So this is Japanese tunnel videos, the construction method. This one. This is the tunnel is a road tunnel, and this is in Japan. So. This called is a surface, tunnel surface, right? All right, this surface, protected the surface. This is a drill jumbo to the boring. This is a hole, drilling hole to the inside of the explosive. This is the workers inside to the explosive. This one. And to the sound roof. So the crows, and then this is explosive. Just a moment, right? I think so. This explosive is the total volume maybe 100 to 20 kilogram, or this one. And this another excavation method is a mechanical excavation. This is to the boom cutter. It's very the weak conditions. This is the mechanical excavation. The double bypass is this use the machinery. Okay, this work. Next is the materials, the marking to out of the tunnels. And this is well loaded, or maybe the 20-ton dump truck is used to the marking. Next to the initial shotcrete. This is the shotcrete machine, spread machine. This one. And the first is so the surface, and then next to the steel arch, maybe H-beam arch. Install to the tunnel release. And next to the tunnel, this is the earth, the second of the initial. This one is. And next to the lock bolt, here's a drawing lock bolt. This one, using the drill jumbo. And to the insert to the mortar and to the lock bolt insert. This is the tunnel cycle, excavation cycle, where the 1.1.5, 2 meters, one cycle the distance. And then next, before this lining concrete, this one, moving to press the concrete. This concrete is one span is 10 meter, 1 cycle, and this one. This is the tunnel, this one. And next to the lighting, the facilities, and the pavement, it finish to the tunnel. This is also the brief tunnel construction videos. Thank you for the listening to the expression our tunnel term. And if you have any further questions, please don't hesitate to reach out to us. Thank you so much. And my presentation is finished. Thank you.
So we have Engineer Alvarez, Engineer NISHIZONO, and Mr. Kimura here for the panel discussion, and also to support DNE. We also have some technical persons in the audience who will answer some technical questions. Mr. Takada Takeyuki, the General Manager, and Sheila May Fernandez, the Engineer 2. Any questions from the audience before we start? Okay, I'll start first with the question. So I'll ask first Mr. Nishizono. Yeah. So my question for you is, what are the key advancements of the new Austrian tunneling method compared to the conventional tunnel boring machines?
So thank you so much for the questions. It is so there are good questions. So there in the Europe part the tunnel is using the TBM is normal. But and the TBM is so I think so the TBM the so machinery is very so high expensive machine. And so in Japan, so the complex geological conditions, so not suitable, TBM is not suitable. And so the TBM is the machine is the stable the diameters, no extend to the cross sections. So not only NTM is very flexible for the enlarge or that small the cross sections. And TBM is very expensive machine. I think so, in my opinion, maybe under 5 kilometers tunnel, it is very it's convenient, suitable for TBM. That is 4 kilometers below, I think it is better to the NTM. Okay.
Thank you so much, Engineer Nishizono. Any question from the audience?
Hello, good afternoon. My question is for Engineer Alrey. Thank you for the very informative information you shared a while ago. I was just taking note of the term you are referring to, pre-engineered buildings, and you were categorically declaring that it's really for bolt connections. So if it's weld connections, it's really not classified under pre-engineered.
Yes. Basically, yes. Because that is the essence of pre-engineered building. We are using bolted connection. That is the essence of that, not welded.
All right. Okay. Thank you for that question, sir. And if it's okay if I have follow-up question. This for Yuichi-san. Thank you for as well for the presentation. I have a question with regards to the existing road alignment that's around the Laguna de Bay. It's called Laguna de Bay Loop. What happens after the Laguna Lake Road Network project is commenced, or maybe after the construction? Will it be decommissioned or will it stay in that?
Just there, I am not the road engineering. I cannot so answer that. But so that I think so that this is a expressway the road in these years. So just in my opinion, so this is the Laguna Lake the shore touch interchange, and maybe the 6, 7, or 8 interchange connected to the existing road and the national road. I think so those very so the convenience to the local residents because to the not the traffic jam that they using this one. I think this is my answers. Okay.
Thank you. Thank you for the answers.
Hello, good afternoon. Just a question, follow-up question to Mr. Yuichi-san. Regarding the TBM and the NATM, can you give like a comparable cost for same diameter tunnel for say 1 kilometer? I don't know, maybe like a 16-meter diameter. What would be the, like the construction cost? And yeah, and then I have a follow-up question later on for Kimura-san. I think you mentioned about that technology for geological mapping. That you don't have to do drilling, but you're just using like that missile-looking apparatus. So how accurate is that? Thank you.
Thank you for the questions. The first question, I mean, this is a tunnel NTM construction cost. Yes. According to the ground conditions, different to the tunnel construction cost. And in my experience in Japan or this and other overseas, maybe 1 meter. So Japanese yen, sorry. 5 million. 5 million yen in Philippine peso. 2 million to 1.1 million, 1 meter. Okay. And but however, the tunnel is there is no need to the ROW. Right of way, because of the maybe the overburden 30 meters with it needed to the ROW. The overburden the 50 meters above there is no the ROWs because of then the tunnel is advantage. The ROW the cost is nothing. That is very small. I think so. This is my questions.
Yeah, thank you very much for your question. Very good question. So in Japan, our survey method, AEM, airborne electromagnetic method, is used the replacement of boring, actual physical boring. But we'd like to propose we need physical boring for calibration purposes. Meaning, for example, we have to drill the limited number, and then we will check the result, the actual boring, and our AEM result. So the two results look same, or maybe we can trust AEM. But sometimes the result different. So meaning we need some more boring and then make some calibration arrangement, modification for our methodology, AEM. Is it okay? Thank you very much.
Hi, good afternoon. My question is directed to Yuichi-san. Hello. Yeah. Considering all the technological advancements in tunnel boring technology, could you possibly say that we are getting closer cost-wise to using a tunnel as against a viaduct in terms of cost? Was there any study about it before or anything like that?
So your question is the comparison viaduct and tunnel.
Yes. Yes, comparison. Cost comparison per se.
Comparison.
Yeah. Is the tunnel boring technology getting cheaper?
Yeah. So fortunately, we have rich engineer today, our boss Takada-san. So Takada-san,
I use your role, yeah?
viaduct, in case of viaduct.
Viaduct versus something like
Good afternoon. So, じゃあ、case of the LLRN phase 2. So, which elevation is a tunnel? The high elevation is a tunnel is a short. However, viaduct is long. Yeah. Compared to the each elevation, that's how we select the minimum cost location. Actually, compared to tunnel and viaduct, so even apply the ashdod girder in common in Philippines, so tunnel is high cost. Still high cost. Depends. Yeah, depends geotechnical condition.
And additional, so there is our engineer, the contractors, focus on the construction cost only. But the maintenance company, the selects to focus on the maintenance cost and facilities or the inspection. This is so comparison the viaduct to the tunnel. It's a tunnel is the high. Tunnel is expensive to the maintenance cost. I think this.
Any question from the audience? Okay. While waiting for the audience to ask, I have one question because I think the discussion's more on is on the cost implications. So, but I'm a passionate person, so let's ask the sustainability. So, what in terms of the sustainability, Mr. Alvarez, and then this is a question for both of you, Mr. Alvarez and Mr. Nishizono. So in terms of the sustainability, how do the tunneling and then the Pebsteel industry are minimizing the impact to the environment?
So the environment impacted is in the construction of tunnels.
Environmental impact in terms of sustainability.
Right. So at first, the environment impacted the water resources and the underground. So in the construction, during the air and the noise pollution construction, the active generate dust and noise. And the next, the waste management to the materials, to excavation materials, they are exposed the tunnels to the transports. And so this is so in my experience, so the water resources and sometimes the resident peoples use the well, and because after the tornado, this well is not good, well, don't work here. In the design stage, which is important, to focus on tornado, the groundwater level. This is a very important factor in the construction stage.
Thank you so much, Mr. Nishizono. Sir, Engineer Alvarez.
Yes, no? Environmental impact. Basically, our company is using steel, right? And you will notice in my presentation, through the technology of pre-engineered building, we are using less steel. You see that? Using grade A36, you will use lots of steel. But using pre-engineered building, you will use less steel. Meaning to say, it will help planet Earth. Remember, the raw materials of steel came from ore, right? If we're going to use less steel, less impact in the environment. That's all.
Hello. Hello. Yeah, I would also like to add something to what Mr. Alvarez has said because in our factory, we are fully automated. So the materials that we use, we have very little wastage. So, and these materials that we consider as waste is also being sold to smelting plants to reproduce as other materials, other steel products. So it's kind of renewable in a way.
Yes, that's true. Renewable. Yeah. Yeah.
Thank you. Okay, I have one more question for Engineer NISHIZONO. How does new Austrian tunneling method align with the global push for infrastructure resilience and smart construction?
Smart construction, what do you mean by smart construction?
Infrastructure resilience and smart construction.
Smart construction. So in Japan, in Japan, I chose the Japan experience, the Japanese status. So as you know, the Japanese so the elder laborers workers is increasing, and the worker is decreasing. So in Japan, the tunnel and method is automatical. So the drilling and marking is automatical. There is a little workers. And in my experience, in 1980, and maybe one tunnel, the worker is maybe 20 or 30 workers in one tunnel. And in existing the Japanese worker, it is maybe 10 or 12. Because so the drill jam and the spread machine, the shortcut machine, it's automatic. So the remote the operation to the out of the tunnels to using the machines, and next to the in Japan, the smart net in Japan, so the workers health. And as you know, the tunnel entrance in here, the many workers check and the entrance is their ID badge and the check and out the check because this is their protected the workers health. This is so the smart and in conclusion. It's smart in NHM. It's so the automatically and the machines and so the protected workers. And they did this Japanese trend. In this question, okay.
Engineer Alvarez, another question. What industries or sector you are seeing the most significant in terms of using the Pebsteel industry?
Basically, the major is in the construction industry, right? Infrastructure. In the construction industry, majority are warehouses. And warehouses is our specialty. But right now, we are doing high rise, medium rise. That's it.
Hi, I'm Julie Mendoza from GHD. Question for Engineer Alvarez. For pre-engineered buildings, how does they perform in the high seismic areas like the Philippines?
Basically, as I discussed before we design everything, we must first indicate the location. And we are using the National Structural Code of the Philippines. through that, we can design it. There are different zone area in the Philippines, you know that. Seismic for everything. That is the first one that we are going to analyze. And the rest will follow.
Follow-up question, if I may. Teddy Melgar from GHD. So the question is, have you done like a residential or commercial building using Pebsteel?
Yes, we did lots of residential and commercial building. Our minimum tonnage that we can deliver is 1 container van. 1 container van is around 14 to 15 metric tons. We can do from that up to upward any metric tons, any amount. We can deliver that. Our company can fabricate 100,000 metric tons per year, meaning to say 10,000 metric tons plus per month.
So far, what is the highest structure that you've been able
The highest structure right now is our Central Link. That is 3 towers, 19-story building. And still, we can do much higher than that. The principle is the same. That's it.
So yung the framing, is it all structural steel or you do it as a composite construction?
It's all structural steel. We will supply from anchor bolt up to the peak, up to the purlins. We will supply that.
Thank you. Good to know.
Yeah. You're welcome. Thank you.
Engineer Alvarez, just a follow-up question from Teddy. Do you have any study on how tall or the level that the Pebsteel could be used for?
How tallest is
the
the
level of
the building?
yes. You mentioned 19 stories, so any studies, because you mentioned it can go higher.
Basically, the structural designing, no? We can do much higher than that. We can do. Because if we are going to design, the principle designing is we are going to start at the top, right? Then going to the bottom. In the construction, it's the reverse. We are going to start at the ground, then going up. No matter how tall it is, Pebsteel can supply it. That's it.
Thank you. Okay. Question, Teddy, you have question? Last. We're going to wrap up.
No, sorry, we're just discussing amongst ourselves. In fact, we remember, maybe some of us can remember also, sometimes it's in the YouTube videos, you know, like old pictures of, I think, Manhattan or New York. I haven't been there, but I've seen in the videos, like very tall structures, structural steel, right? So, yeah, so I suppose in terms of how high the structure, it depends on the design, but yes. But sorry, so the question is like, perhaps the question is, are you getting interest from local developers, for example, for perhaps higher story buildings?
Yes.
The region support is
Of course, yes. Yes. We are very much interested for that.
No, but so you don't have yet anybody who has approached you to, you know, like look at a 30, 40-story building and construct it using
Alas,
structural steel.
there are.
Okay.
Hi, sir. We're just asking on the height limitations for structural steel in the Philippines because in our code, the response modification factor, the R value, we have a limit for that.
Yes. We know that. That is the reason what we need is the architectural plan, no? And then after that, we are going to study normally the area because there are some areas that there is a limitation in the height. For example, I have a project in SBMA, Subic Bay. The building, as per plan, was designed up to 4 story. but it is along the road. They are not allowed to do more than a 4-story. Then it reduced to 2-story. It's like that. Just send to us the architectural plan.
Okay, I think that's wrap up the questions from the audience and every. Thank you so much for the questions. Before we end this one, this panel discussion, may I ask any final word to Engineer NISHIZONO, Mr. KIMURA, and then Engineer Alvarez. Probably Engineer Alvarez, would you like to start? Any final words?
As I said before, lots of changes are happening, right? Only one. Let us adapt to change. That's all. Thank you very much.
Thank you.
At first, the presentation our is PICC. So the Mr. Kimura said it is online and the presentation, no problem with this. Like I said, the answer is no problem presentation. But also I decided to do face-to-face presentation because of from the Japan. So thank you so much. Thank you. Sorry, to give me the opportunity to the presentation and TM. So I would like to explore to the mountain tunnel in the Philippines. So I think so that it's a very increasing tunnels. So I will support. I will contribute to the Philippine tunnel project. Thank you so much. Thank you. ありがとうございました。
Okay, yeah, today's presentation, particularly the steel design and the new Austrian tunneling method, was quite impressive and very informative for all of us. It is actually good to know that the design is really evolving to match what we really need for future use. So thank you for joining the panel discussion.